So we're in section 3.8, and we want to use we're using coordinates with polygons. And what I mean by coordinates is we're graphing points. So we have a graph of a polygon, and we want to figure out what kind it is. We have some points, and we want to figure out what we know about the segment that goes between those points. We're using points, x and y points, and we're graphing those points and figuring things out about them. So the first thing that we want to talk about today is slope. So what do we know about slope? What is slope? So it's something that we learned before. In what context do we learn? Graphing, and it had to do usually with lines. What did it tell us about the lines? Down 1 over 2? Rise over run. There we go. So slope has to do with rise over run. And what did it tell us about the lines? Did it tell us how far apart? How to make, it has something to do with the make the line, but the slope, what did the slope tell us about the line? Where it was, what color it was, what its friends were, or what? So distance to the one point, and you're kind of moving your line over and dropping it down. Does that tell us how slanted it is? Or how steep the line is? If the slope is big, the line is steep. If the slope is small, the line's not very steep. Or if you think about a roof, if you think about the slope of a roof, if the slope is big, the roof's slanted. If the slope's not very big, it's not very slanted. So it has to do with how slanted or how steep. So the slope tells us about these kinds of things. What we want to do is figure out how we calculate slope, and two, what it can tell us about polygons. So to calculate the slope between 2 points, and our points are x1, y1, and x2, y2, is y2 minus y1 over x2 minus x1. So this is our slope formula. This is how we figure out the slope of a segment between 2 points. You take the y2 minus y1, that tells us how far up and down we're going, so that's our rise. And the difference in the x coordinates, left and right, that's our run. So this is how we find the slope of the segment between 2 points. So let's look at an example of how we calculate with slope. We're going to do several formulas, and then we'll do an example of using them with polygons. So if we want the slope, we want to find So we want the slope of the segment between the points negative 2, 5 and 4, 8. Now what I recommend you do with all of these formulas is label the points. And what I mean by label the points is we'll call one set x1, y1, the other set x2, y2. So I'm just going to call this x1, y1, and this x2, y2. It doesn't matter which pair you call x1, y1, and x2, y2, as long as you keep the 1's together and the 2's together. So I could do it in any order as long as I keep the 1's and the 2's together. So now I just plug these points into my formula. The slope equals y2 minus y1 divided by x2 is 4 minus x1 negative 2 8 minus 5 is 3. 4 minus negative 2, positive 6. Minus a negative makes it positive. So I reduce that fraction and I get 1/2. So the slope of the segment between those points is 1/2. So for every 1 square it rises, it goes over 2. So this would be the rise and that would be the run.
Now, doesn't that change the slope though? Because if the non-reduced answer is 3/6, it'd be a steep slope, wouldn't it?
No, because for every 3, so you go over 3, or sorry, you go up 3 and over 6. That's the same as going over 1, or up 1 and over 2. It's still for every one of these that you go 2 of these. So this is still 2 times that, so it's still 1/2. So we can still reduce the fraction. Now the way we use slope with polygons is to decide if lines are parallel or perpendicular. That's how we use slope. And this is another thing that you talked about with lines before when you did graphing. So slope tells us if lines are parallel or perpendicular. And this is how we tell. 2 lines are parallel. If and only if, so this is a definition, if and only if their slopes are the same. So we know 2 lines are parallel if their slopes are equal. And vertical lines are always parallel. So we can compare the slopes of 2 lines. If the slopes are exactly the same, then we know that the lines are parallel. We can also tell if they're perpendicular. 2 lines are perpendicular. If and only if their slopes, you remember the rule for perpendicular lines, are anybody remember the rule for perpendicular lines and slopes? If and only if their slopes are negative reciprocals. So what we mean by negative reciprocal is if we had a slope of, we calculate a slope of 1/2, we flip the fraction and change the sign. So negative reciprocal, 1/2 would turn into negative 2 over 1. 3/4 would turn into negative 4/3. Negative 7/8 would turn into 8/7. 2, I'll do 3. 3, we can think of 3 as 3 over 1. 3 would turn into negative 1/3. So all of these fractions are negative reciprocals. We flip the fraction and change the sign. So if we find the slopes of 2 lines and they are negative reciprocals, we know that the lines are perpendicular. And any vertical line is always perpendicular to any horizontal line. No, the quiz tomorrow is just an angle puzzle. All right, we have a couple more formulas and then I'll show you how we use all of these things. So this is what we do with slope. We decide if two lines are parallel or perpendicular. So if we have a shape that's graphed, we can tell if the two opposite sides are parallel by comparing their slopes. We can tell if the two sides next to each other make a 90-degree angle by looking at their slopes. Let's look at the distance formula. So the distance formula is how we figure out if we have coordinates, if we have points graphed, we want to figure out the length of a segment. How long, if we have a polygon graph, we want to figure out how long the side is. So the distance formula. The distance between x1, y1 and x2, y2 is, the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we have points graphed, this is how we tell how far it is between those points, how long a segment is if we have 2 points graphed. So if we wanted to know if a polygon was a rectangle, we would need to know that the opposite sides were parallel and that the opposite sides had the same length. The distance formula is how we figure out length. Let's look at an example of calculating with the distance formula. So we want to find the distance between 3, 5 and 7, -2. So again, I suggest that you label your points. I'm going to call this one x1, y1, x2, y2. It doesn't matter which one you call x1, y1, x2, y2, as long as you keep the 1's together and the 2's together. So my distance is the square root of y2 minus y1, -2 minus 5, and we square that, plus x2 minus x1, 7 minus 3, and we square that. -2 minus 5 is what? -7, and we're squaring that. Plus 7 minus 3 is 4, and we're squaring that. Now here's where a lot of people make a mistake with the distance formula. When I square a negative number, I always get a positive number. You should never end up with negative numbers in the distance formula. Yes?
Did you say it's generally with x minus x1 and then y minus y?
Yeah, that's what I did. Oh, I switched them around. If I did y2 first, I can turn these two around. I just did them in a different order. But thank you. I should, to be consistent, I should have put the x's first, but I can do them in either order. But I should never end up with a negative number under the square root here. So I get the square root of 7 squared is 49, and 4 squared is 16. So I get the square root, 49 plus 16 is 65. So the distance is the square root of 65, and then I would just plug that into my calculator. So let me grab my calculator, find the square root of 65. And I get about 8.06. So I'm going to say that's about 8.1. So the length of the segment between those 2 points would be about 8.1 units long. But I should never get a negative number in the distance formula here. When I square these numbers, they should always turn out positive. So you always end up adding numbers together here. All right, so let's take a look at an example, and this is the type of problem that you'll see in your homework. of how we're going to use the slopes and the distance formulas. So let me set up my new page here, because I want a graph page. Okay, so there we go. All right, so for this example, we're going to plot. We have some points. We want to plot the quadrilateral QUAD, where Q is 1, 4, U is 7, 8, and A is 9, 5, and D is 3, 1. And we want to figure out what kind of polygon. All right, so let's draw some axes here. And I'm going to go over here. All right, so we're going to plot these points. So we're going to go over 1, up 1, 2, 3, 4. There's point Q. U is over 7, 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4, 5, 6, 7, 8. There's point U. A is over 9, so we're 7 here, 8, 9, and up 1, 2, 3, 4, 5. And that's A. And D is over 1, 2, 3, and up 1. And we're going to connect those points.
Yeah, label D.
All right, I'll get that in just a second. All right, there's point B. So there's my quadrilateral. We want to know what kind of polygon is it. Well, what does it look like? It could be. Looks like it could be a rectangle. I guess it could be a parallelogram also, right? It could be a quadrilateral if none of the sides were parallel, if there weren't any special angles, it would just be a quadrilateral. In order to figure it out, when we have these points, we need to compare the slopes of the sides. If the slopes of the opposite sides are parallel, if the slopes of the opposite sides are the same, then the opposite sides are parallel. If the slopes of these two sides are negative reciprocals, then those two sides make a 90-degree angle, and that would tell us that this is a 90-degree angle. If the lengths of the segments are the same, that would tell us that the opposite sides were the same length. So we need to figure out all of that stuff if we wanted to decide if this were a rectangle. So let's calculate some slopes. I'm going to do the slopes in red, and I'm going to shortcut some of the calculations just to make it last a little longer, or not last quite as long. Sorry. The slope. So we want the slope of the segment between QU. So our slope equals, for QU, y2 minus y1, I'm going to say 8 minus 4, over x2 minus x1, 7 minus 1, and I get 8 minus 4 is 4/6, and I reduce that, and I get 2/3. So that's the slope of QU. Let's look at the slope of DA and see if they're parallel. So the slope of DA. So here's D and here's A. So y2 minus y1 for DA, sorry, DA. 1 minus 5. And 3 minus 9. So I get 1 minus 5 is negative 4, and 3 minus 9 is negative 6, and I reduce that, and I get 2/3. Those two slopes are the same. That tells me that these two sides are parallel. So we know that these two sides are parallel. Let's look at the slope of QD. The slope of QD. So here's Q and here's D. Y2, 1 minus 4. X2, 3 minus 1. 1 minus 4 is negative 3. 3 minus 1 is 2. They are negative reciprocals of each other. So QD is perpendicular to QA and QU. So these angles are 90 degrees. That tells us that these angles are 90 degrees. Let's look at the slope of the last side, UA. The slope of UA, let's get our point here. U and A are here. Y2 minus Y1, 5 minus 8. X2 minus X1, 9 minus 7. 5 minus 8 is negative 3. 9 minus 7 is 2. So that tells us that these two sides are parallel, and this side is perpendicular to the other two sides. So we know that opposite sides are parallel, and that we have 90-degree angles. So when opposite sides are parallel, and we have 90-degree angles, what does that tell us that our shape is? A rectangle. So this tells us that our shape is a rectangle. Our shape is a rectangle. And we did that by comparing our slopes. We could also use the distance formula and calculate the lengths of the opposite sides and make sure that they're the same length. But because we have opposite sides parallel and 90-degree angles, that guarantees us that we have a rectangle. Yes?
Now, the UA, I did 7 minus 9 on top, and I got maybe 2 over 3. And then
UA 7, 7 and 9 are the x's. You want your y's on top.
okay.
7 and 9 are the x's. So for the slope, the y's always go on top.
Okay.
Always. Because we want rise. The rise is up and down. So the rise is always the y's. All right, questions on this? So this is the kind of question that you'll have on your homework, calculating these slopes to figure out what kind of quadrilateral you have. All right, I just want to talk about one more formula that we need, and then we'll be done. I don't want this. I want a regular page, so I can get this. This is the page setup. This, okay. All right. The midpoint formula. If we want the middle, if we want to figure out exactly the middle of a segment, there are a lot of formulas. This is the last little bit that we're doing now. We're almost done. The midpoint. Of a segment between 2 points, our points x1, y1, and x2, y2, is equals x1 plus x2 divided by 2, and y1 plus y2 guys, divided by 2. The important thing to remember about the midpoint formula is it gives you a point, not a number. So this is a coordinate. This is x, and this is y. It gives us a point, not a number. So we add the 2 x coordinates, divide by 2, add the 2 y coordinates, and divide by 2. And we get an x and a y. We get a point. That's a lot of people confuse a midpoint formula. They think you get a number, because all of our other formulas we've gotten a number. This one we get a point, a number for the x coordinate and a number for the y coordinate. All right, let's do a quick example of calculating a midpoint, and then we are done. We want to find the midpoint between 2, 3 and 6, negative 6. So we want to find the midpoint between these 2 points. So our midpoint, again, I recommend labeling your points, x1, y1, x2, y2, and then we plug this into our formula. Our midpoint is x1 plus x2, 2 plus 6, divided by 2, and that's our x coordinate. And then y1 plus y2, 3 plus negative 6, divided by 2. And remember, this is an x and a y. We don't add these together. 3 plus 6 is 8 divided by 2. 3 plus negative 6 is not 0. Negative 3 divided by 2. So my midpoint would be 8 divided by 2 is 4, and 3 halves is negative 3 halves is negative 1.5. So the point that's halfway between 2, 3 and 6, negative 6 is 4, negative 1.5. That would be halfway between those two. And again, remember that the midpoint gives you an x and a y, not just one number. All right, questions? Okay. Oh.